Hello everyone, welcome to the NN Classroom. Today I'd like to share with you a past paper question from 2019 Time Zone 1 in May. So that is question number 15, relating to topic 5, energetics, enthalpy change calculation in particular, asking what is the enthalpy change of reaction? So that is the delta H for the following equation. So that means this is our target and I'm going to find out the delta H based on the given information. So if we look at carefully, students should have first recognized that the x, the y, and the z are all relating to the particular equation. And these equations are actually having a common feature. Those are all reaction with oxygen. And the basic reaction that is basically concerning with the reaction with oxygen is what we call combustion. And if with this bear in mind, all the reactants, that is the fuel that is being burned, are in 1 mole. Basically, these are all fulfilling the definition of the enthalpy change of combustion. So that's why for the X, actually, the interpretation for this, for our mindset, is that this is going to be the delta HC. C stands for combustion, right? Of the C2H4 gas, right? The next, Y is actually focusing on the delta H of combustion of the fuel. This time the fuel, that is C2H6G. And finally, for Z is actually still a combustion, right? Although it's going to be explosive, still this is said to be combustion because anything plus oxygen gas means it's going to be burning, right? So combustion of hydrogen gas, right? With this interpretation, then students should be recognizing a really important shortcut that we have learned that this time we can apply it, is that any delta H of reaction can be summarized as the sum of the delta H of combustion of all the reactants, subtract sum of the delta H of combustion of all the product, P, right? So this is the shortcut that normally teachers, textbooks, all the materials relating to this topic should have demonstrated, plus another shortcut using formation, right? But that is product minus reactant. For combustion, remind you that is reactant minus product. Basically, that is the application of the Hess's law, right? With this shortcut, so now the question make it so simple. The delta H of the reaction is our target this time, right? So this is the delta H of the RXN reaction. So that will be equals to the reactant's combustion. So this time the reactant goes to the delta HC of the C2H4 as the first reactant, G. And how many moles of it? Only one, so perfect, right? Plus the second reactant, because we need all the reactants, right? So that's the second reactant, or hydrogen gas. So we need the combustion of hydrogen gas, right? And then this will be the sum of the combustion of reactant. Then subtract the sum of the combustion of product. So this time our product only goes to C2H6 as the product of this reaction. So that's why that will be the delta HC of the product, C2H6G, right? So that's simple. So eventually, after we establish this equation or this application of the Hess's law, then we can simply find back the corresponding notation, right? So C2H4, which is going to be X, and then combustion of hydrogen gas, which is going to be Y, so X plus Y, and finally subtract, X plus Z, mistake, plus combustion of hydrogen, so this one, so that is Z, so that's X plus Z, and finally subtract C2H6, so this is C2H6, combustion, that is Y, right? So that's how the answer will be X plus Z minus Y, right? So that's how the correct expression, which is going to be X plus Z minus Y, so D.